So today we are going to start on the other type of technique in the organic chemistry, which is very, very popular, and this is the distillation of fractional distillation. So as you can see here, I put together the apparatus, and this is the model for today. So then all the students will be able to set up their own. The only difference from the simple versus the fractional, we are going to need extra glassware. And this one here is, we call it the air condenser. Air condenser, we're going to pack it with the stainless steel, which is, in this case, we are trying to mimic the actual apparatus for the in the industry, which is usually comes with the level, like, you know, layers, with different layers, and the vapor will go through these layers, and that's how we will be able to separate different components according to their different temperature. So as you can see, this is the air condenser filled with the very, very light, and it shouldn't be too much packing, otherwise we're going to abstract the vapor from going all the way to the condenser. And then I'm going to set up the condenser the same way, coming in from the water tab, water, and going out to the sink from the top outlet. So that's definitely, it's exactly the same as what we had in the previous type of distillation, which is the simple distillation. So the only difference, as I mentioned here before, is going to be, I'm trying to make sure that it's not going to splash on our face. But anyway, so that's how we're going to get it. Goes out the water, and then we're going to have the thermometer. So thermometers, we are trying to get into at least a thermometer with a 150 degrees Celsius, because our chemicals, as you can see there, it is actually the highest is the toluene, which is 110. So we want to have this range of that's what we are expecting. So basically, this is the apparatus for our own experiment today, which is a fractional distillation. As you can see here, we have those three different combinations, or like with a diagram. And as you can see here, we have only one component, and this is how it looks like. It's one expected. We know the temperature, which is the boiling temperature in the reference, and this is what we expect. When we did the simple distillation last session, the separation was not 100%. We had a range on this area when we were able to separate both components. Let's say I'm going to have cyclohexane, which is 80.75 degrees, and toluene, which is 110. Most of the students, if not all of them, they were able to separate an electrodes around the middle between those two, which was 90, right? Is that right, everybody? Around 90, you were able to separate an electrodes of maybe 1 mil, because we are using microscale. So anyway, today, hopefully, with the air condenser and the stainless steel, which is going to mimic the apparatus for fractional distillation, we expect to have a better separation, isolation, purification of the two components. So as you can see, this is the diagram. So if A is going to be separated first at around 80, then we're going to have a buffer between the two, and then at 100 maybe, or 99, we will expect to have the other one. So this is what we are going to expect today. As for the apparatus, so the only part that it is going to be added to the simple distillation is this part. As I showed you in our model, we are going to have the air condenser filled with stainless steel. We have both, either you are able to use the Ramba and flask with 10 milliliter, or you can use the the cuvette, this one, which is small, it is 5 milliliter. So both are available to you, you can have it, it is in the kit. If you decided to use a small cuvette, this one is only 5 milliliters, so what I would do, I will have 2.5 milliliter for each one of the component that you're going to pick, whether it is going to be toluene with hexane or toluene with cyclohexane. By the way, I want you to pick the same exact combination. Don't use different today, because you are going to compare between simple versus, this is our analysis today. We want to compare the two types of distillation. The distillation in the simple technique and in the fractional. And we will be able to calculate the molar fraction, okay? The calculation of molar fraction, and then how you are going to see the percentage for each one of the components, as I showed you in the previous one. Okay? So this is what we are going to do today. The only part that we have to add to our simple apparatus of simple distillation is the air condenser. Don't forget, we're still going to use the condenser, the water condenser water in. So here is the in and here is the out. Always. Here is the in and here is the out water. And this is the water. Okay? So this is basically what we are doing today. All right? And here are the apparatus. All right, let me show you the apparatus. Here we are. This is the apparatus. Okay. All right. Thank you. I'm recording when it is. No, this is the when you can. And it is going to have each one of the component according to their boiling point. They will be separated. So if we look at those three diagrams, the first one, when we have only one component, this is only one, this is what we expected, what we predicted, and it is going to be very straightforward. Last session, we had the simple distillation, and as I mentioned before, most of the students will have an aliquot between the first component and the last component. So let's say we are going to use toluene, which is 110 almost, and the other one is the cyclohexane, which is 80. So most of the students had something in between that. They actually were able to separate around 80 degrees the first component, which is, in this case, is the cyclohexane. Then they were able to separate something after they had a level off. At 90, they were able, this is the mix between the two. Because it is during the simple distillation, we will have a time when the higher will go down temperature, and the lower will get into that. So into that around, in this region between the two, which is around 90 degrees, and it is going to have a mixture. Hopefully, what we are hoping today is we will be able to have the separation between A and B through the fractional distillation. Because of what we added this part in the apparatus, which is going to be packed with a stainless steel, and it is going to allow those two components to be separated more properly. So hopefully, that's what we are hoping, that today you're going to have a very, very distinguished area between, or like time between the first component and the last component with a higher temperature. In other words, we will expect to have, hopefully, the first one around 78, 79, and the last one, after that, you're going to have like, you know, a level off or a period between the two that there is no dripping, and then we will be able to collect the second component. Don't throw it away. You need to weigh your container, and then after you add, like, you know, you're going to start collecting the drops. You're going to weigh it again, because remember, we need the weight, we need the volume. From the volume, we will be able to calculate the weight from the density, okay? So that's how we did it last time. We're going to do it this time again, but with a different apparatus. And as I mentioned, the only difference is the addition of the stainless steel. So as you can see here, we were able to pack this with a stainless steel, and I'm going to do that for every single apparatus that we are having today with the rest of the class. So this is the model of our apparatus. Is exactly the same. We are using Hickman head. This is the cuvette, and then also we have the the air condenser and the water condenser, as we did use it before. Don't forget the thermometer. Every single one of those adapter or connection, don't forget to also grease it, because it is very important. We don't want to have anything get stuck after it is going to be expanded through the heating. Okay? Do you have any question for me? Okay, so hopefully, whatever you used last session, all right, for the simple, use the same exact combination. Don't use different one. Because at the end of the day, we want to compare between the two, and we want to find out which one is more efficient separation of those two compounds. Thank you very much.